In this video, we're going to talk about something called the law of sines. This is going to be very useful when we're working with triangles that are not necessarily right triangles. So it turns out that when you have a triangle, such as triangle ABC here, that the sine of the angles and their corresponding sides actually are in proportions to each other. So for instance, the side across from angle A, we're going to label that lowercase a, side across from B is lowercase b, and so on. So the law of sines states that the sine of angle A over side A is equal to the sine of angle B over side B, and that is also equal to the sine of angle C over side C. So let's look at an example of how this could be very useful to us. So let's say we're given a problem such as this, where we have angle A, and we have side A, and we have one other angle, which in this case would be angle B. Solving triangle ABC is really asking you to find all three angles and all three sides of that triangle. So let's think about this. You know, drawing a picture is probably a really good idea to see what's actually going on here. Just, help you organize your thoughts. Let's label this ABC. So we can label angle A as 26 degrees, side A is over here, that's 15, and angle B is 103 degrees. Okay, so we know some basic facts about triangles, such as the angles have to add up to 180. So if we know two of the angles, we automatically are going to know the third angle, right? So I'm going to say that angle C, measure of angle C, is going to be 180 minus 103 minus 26, right? So that's going to be 51 degrees. So I'm going to label that in my picture. Let me keep this in green so I know that that's something that I actually had to find that wasn't given to me. So the other thing that I'm going to also set up right now is a little chart. And whenever we're solving triangles, this chart just kind of, again, helps us organize our information, seeing what we know and what we don't know. So we need to find sides and angles. So I'm going to put all my angles over here. And let's keep that going here. All my sides here. Okay, so let's fill in what we know. Angle A is 26 degrees, B is 103, and C is 51. Okay, so law of sines says that we can take sine of any of the angles. Let's do sine of 26 degrees. And we can put that over the side across from that angle, 15. So that would make sense why I'd have to use angle A, since side A, is the only side I actually know right now. I know both other angles, right? So we could use sine of, let's say, angle B, so that's 103 degrees, and that's going to be over side B. This is great. I have one variable I can solve for, so let's go ahead and do that. I'm going to cross multiply. Now I'm going to get B by itself, divide by sine 26 degrees on both sides. And notice that I haven't touched my calculator yet. I'm going to get B completely by itself so that I have the exact answer right here on my paper, which would be 15 times sine 103 over sine 26 degrees. And now I will type that in my calculator for an approximation. 15 sine 103 divided by sine 26. Don't forget that we want to make sure that we are in degrees. I have to actually switch over mine to degrees. And I get that side B is approximately 33.341. So let's fill that into our chart. We already knew side A, we might as well fill that in too. And that means we're just missing side C. So what I'm going to do is basically the same thing we just did to find side B, but instead we're going to set that sine 26 degrees over 15 equal to sine 51 degrees over side C. So now let's repeat that. C times sine 26 degrees equals 15 sine 51 degrees. Right, that's from cross multiplying. Now we'll divide by sine 26 again. So C is 15 sine 51 degrees divided by sine 26 degrees. And according to my calculator, that is approximately 26.592. And we'll fill that into our chart. And now you can see we have all three angles and all three sides. Now, I'm going to backtrack for a second. We were given an angle, side part of the triangle. Remember when you used to prove triangle congruent? Right? In this case, since the side is not in between those two angles, this would be a AAS case. So we only would have one possible triangle. That might not make a lot of sense what I just said until you see some other examples. So let's go ahead to another example. So in this example, look at the information that we're given. This time we have an angle and two sides. And in this situation, the angle is not nestled between those two sides. So this would be the SSA case, which, if you remember back in geometry, was something that you could not use to prove triangles congruent. And that was because you sometimes are able to make two triangles from that given information. We're going to find out right now if, first of all, if this triangle is possible, if it has only one set of values to make it true, or does it have two sets of values to make it true. So let's go ahead, make our chart here. Let's fill in our angles and sides that we know. So angle A is 30 degrees, side A is 20, and side C is 16. Alright, so if we're going to use law of sines, we have to use an angle and the side across from it. So I'm going to set up sine 30 degrees over 20 is equal to, well, the only other piece of information that I have is side C, right? So that's going to have to go down here in the bottom. That means I'm going to have to use sine of angle C on the top. So we're going to be finding angle C first. So I'm going to cross multiply. Now, sine of 30 degrees is 1/2. We might as well just change this 16 sine 30 into an 8. Divide by 20. So sine of C equals 8/20. And we're going to have to use sine inverse of 8/20 to find out what C is. Now remember, with sine inverse, you are only going to get one answer in your calculator. So let's figure out what that answer is right now. Go to our calculators. And my answers are in degrees already, so I'm going to make sure that my mode is in degrees. And I get that C is approximately 23.578 degrees. So your calculator gives you that one angle, and you have to remember, well, there's another possibility. Right? When I set up my all students take calculus, I just found an angle in quadrant 3. Right there, that's 23 something degrees. But sine is also positive in the second quadrant. If that reference angle was 23 degrees, what would this angle be? Well, 180 minus 23 would be 157 degrees. Could the triangle have an angle of 30, an angle of 157, and another angle to add up to 180? No, that can't possibly happen because already we'd be over 180. So we know that that second angle wouldn't make any sense. So this answer for angle C is the only possible solution we have so far for this triangle. Okay, so now, how are we going to find side B and angle B? Well, angle B should be pretty easy. Since all the angles have to add up to 180, we know that we're going to do 180 minus 30 minus 23.578. So angle B is 126.422 degrees. And now we're going to find side B. So we can use sine of angle A again, right? That's sine 30 over 20. That's going to equal sine of the new angle we just found, angle B, which is 126.422 degrees over side B. Okay, here we go again. Cross multiply. B sine 30 degrees equals 20 times sine 126.422 degrees. Divide by sine 30, which again is 1/2, so you could just replace it with the 1/2. And just a note, I've also said this before, notice that we've done a lot of rounding already. We only rounded when we absolutely needed to round. That way we all get the same answer. Think of that. When your teacher's grading your test, you should round the exact same thing that your teacher rounds to. So far, I've already had to round twice for angle B and angle C, and I'm going to be using one of those angles in this calculation. We should all have the same answer. If we were to round multiple times before we ever got to those answers, we would have different answers. Okay? So you need to make sure that you're only rounding when you absolutely need to. So I am typing in my calculator right now 20 sine 126.422 divided by sine 30. And I have side B is approximately 32.187. Right, so we should all have exactly the same answers in our grid here. So it was possible to make one triangle from this given information. In videos to follow, you will see some examples of possibly triangles that can't exist in the first place, or maybe where information is given and there will be multiple triangles that could be made. Alright, time for you to practice. Good luck!